What's up, guys? Welcome to Rational Expressions Part 2. Here we are going to learn how to add and subtract rational expressions. So, let's get off and running and let's add these mugs. Let's go 4x squared plus 3 over xy, and let's add 2x over 3x squared y cubed. Okay, how you start these problems is you do what we did in the last video. You find the least common denominator. Do that first. So start with the numbers. Here there's an unwritten 1. So what's the least common multiple of 1 and 3? Well, that would be 3. Now, x and x squared, what do they both go into? X squared. Y and y cubed, what do they both go into? Y cubed. That right there is our least common denominator. So what we do with that is what we're going to do is we're going to make these two denominators equal to this. So, am I really going to need to change this one? Well, no, because these two are already same. So this rational expression is not going to change, since it already contains our least common denominator. Over here, however, we've got xy, and we need it to be 3x squared y cubed. Well, I'm going to need to multiply it by 3 to get to this, but I'm also going to need to multiply the x by x to get to x squared. And I'm also going to need to multiply the y by y squared to get to y cubed. So I'm going to multiply this whole side over here by 3xy squared over 3xy squared. Okay? Because if you think about it, 3xy squared over 3xy squared is just 1. So I'm not really changing this, I'm just going to rewrite it and manipulate it a little bit so that I can finish out this problem. So, on bottom, 3xy squared times xy gives me 3x squared y cubed, which is exactly what we want. We want these two numbers, or these two denominators, to be the same. Now, up top, I need to distribute that into each term. So 3xy squared times 4x squared gives me 12x cubed y squared plus 9xy squared. Now we just have a fraction with a common denominator. So I can just add up top. So I get 12x cubed y squared plus 9xy squared, oh, I'm going to run out of room, plus 2x, all of that over 3x squared y cubed. Okay? So now, up top, I could pull out an x out of all of these terms. So I could go x, and I could cancel an x here. Okay? We'll worry about simplifying later. I just want you to be able to add and subtract right now. Okay? So, let's do another example. Let's go with 2x over 3x squared y, and let's subtract 3 over 6xy squared. Okay, so again, first thing we're going to find is the least common denominator. Start with our numbers. 3 and 6, what do they both go into? 6. X squared and x, what do they both go into? X squared. Y and y squared, what do they both go into? Y squared. So that right there is our least common denominator. That's what we want. That's what we want both of our denominators to be. So, what do I need to multiply 3x squared y by to get to this? Well, 3 to 6, I need to multiply it by 2. And then x squared to x squared, well that doesn't need to change. Y to y squared, however, I need to change that. I need to multiply y by y to get to y squared. So I'm going to multiply this by 2y over 2y. Over here, 6 to 6, well that doesn't really need to change. X to x squared, however, that needs to change. I need to multiply this by x, and y to y squared doesn't need to change. So all I need to multiply by is x over x. So over here I get 4xy over 6x squared y squared minus 3x over 6x squared y squared. So now I just subtract the tops. I've got 4xy minus 3x over 6x squared y squared. Okay? And that is adding and subtracting rational expressions.